Hello everyone, welcome back to our channel. Today we are diving into the world of routing and we are going to understand the fundamentals of configuring the static routes. Before we jump into the configuration, make sure you hit the subscribe button and ring the notification bell to stay updated on all the things related to networking. Before we jump into the configuration, let's quickly understand what static routing is. So static routing is a form of routing that occur when a router use a manually configured routing entry rather than the information received from the dynamic routing protocols. So in many cases, static routes are manually configured by a network administrator by adding entries into the routing table. This may not always be the case. Unlike the dynamic routing, static routing are fixed and do not change if the network is changed or reconfigured. So static routing and dynamic routing are not mutually exclusive. Both dynamic routing and static routing are usually used on a router to maximize the routing efficiency and to provide a backup in case of dynamic routing information failed to exchange. So static routing can also be used in stub network or to provide a gateway to the last resort. So static routing may have following uses. So static routing can be used to define an exit point for a router when no other routers are available or necessary. So this is called a default route. A static routing can be used for a small network that require one or two routes. This is often more efficient since a link is not being wasted by exchanging a dynamic routing information. And moreover, static routing is often used as a complement to dynamic routing to provide a fail-safe backup if the dynamic route is unavailable. And also the static routing is often used to help transfer routing information from one routing protocol to another routing protocol. This is known as route redistribution, which we are going to cover up later. And there are a few advantages of static routing. So static routing cause very little load on the CPU of a router and produce no traffic to other routers. Static routing leaves the network administrator with full control over the routing behavior in the network, and it is very easy to configure on a small network. So there are few disadvantages of static routing. So first is human error. So in case if we configure the static routing manually, there is a chance that we might have provided a wrong input. So this may create a incorrect routing path by mistake. Another disadvantage of fault tolerance. The static routing is not fault tolerant. This means that when there is a change in the network or the failure occurs between two statically defined devices, traffic will not be rerouted. We have to manually modify the static routes which is configured on the device. Another one is administrative distance. So static routes typically take the precedence over the routes configured and with the dynamic routing protocols. As the AD value of static route is low, so it will always prefer the static route which is configured. So in today's lab we are taking three routers which are connected through the serial cables R1, R2 and R3, and these are the IP configurations which are done on the interface, and loopbacks are created on the router. Today we are going to use this command IP route, and this will be the network and host ID, and we have to provide the subnet mask. So we will configure, and we have to provide the next hop address. So we will configure this command. This command will help us to configure the static route on the device. There are some prerequisites. We have to take the routers and we have to name them as R1, R2, R3, and then we have to configure the initial configurations. So in initial configurations we have to provide the IP address to the interfaces. We have to create a loopback address. So we are going to do the initial configuration, then we will move into the routing parts. So let's move into the lab. We will take a new project and we will name as static routing. Now we will take three routers. So we will connect these interfaces. So we have connected two interfaces, then we will connect fast Ethernet 1/0 to fast Ethernet 1/0. So we have taken fast Ethernet 0/0 to fast Ethernet 0/0 of R2, and then we have connected from fast Ethernet 0/1 to 0/1 of R3. So this is the topology which we need to create. We have connected three routers using the fast Ethernet interfaces. These are the IP addressing which need to be configured on the interface, and these are the loopback IP address which we need to create on the device. So moving into next, we will restart all the devices and open the console of all the three routers. So all the devices are start. We will click on this console connect to all nodes. We will click on this. It will open the console access to all the devices. So now we are in the console of all the three routers. So after boot up, you can able to see this is R1 router. Similarly, this is R2 and R3. So this is R3 router and this is R2 router. So now first we will configure the IP addressing so that we can start the static routing part. So to configure the static routing, first we have to get into the configure terminal. Then we have to get into the interface on which we want to configure the IP address. So we will get into interface fast Ethernet 0x0 and we will configure the IP address. So command will be IP address, then IP will be 10.61.12.1 we will give on the R1 router, then subnet mask will be 255.255.252. So we are configuring /30 IP address, so it will be 252 and then we have to do no shut. Now we will configure the loopback IP address. So we will type interface loopback 0 and then simply type the IP address. So by default loopback address is up, we cannot shut that interface, so it will always be up. We will configure IP address 10.61.10.1 61.10.1 subnet mask will be 255.255.0. So this way we will configure the IP address on R1. If you want to check, you have to run a command do show IP interface brief. So this will show you that fast Ethernet 0x0 having this IP address, status is up and loopback IP address is this one. So this way you can verify. If you run the command do show running configuration, so it will also show you the interface configuration. So we have created a loopback with this IP configuration and we have configured a fast Ethernet 0x0 which will show you the subnet mask also, which subnet mask is configured. So similarly we are going to configure the R2 router. So in R2 we have to configure both the interfaces of F0x0 and F1x0 and we have to create a loopback IP address. So we will get into configure terminal, then interface fast Ethernet 0x0. We will configure IP address 10.61.12.2 and we will do no shut. Now we will get into interface F1x0 and then IP address 10.61.23.1 and do no shut. So this way we have configured the IP on both the interfaces. Now we are going to create a loopback IP address. So we will do create a loopback interface loopback 1 or 0 and then IP address 10.61.20.1 and then subnet mask. So if you run the command do show IP interface brief, now it will show you both the interface having the IP configuration along with the loopback address which we have created. Similarly we will create an configuration for router R3 also. So we will get into configure terminal, then we will get into interface F fast Ethernet 1x0 . Similarly we will do the configuration of router R3. So we will get into interface FA 1x0, then IP address 10.61.23.2 and do no shut. Now we will create loopback interface and configure the IP address. So IP will be 10.61.30.0/24 255.0 So we will configure the IP on the loopback interface. It should be 30.1. So this way we have configured the IP addressing on all the devices. So we have done with the IP address configuration on all the equipments, all the routers which is available in our network. So we will move into the next part. So we have three different so we have done the configurations on all the interfaces. Now we will move into our objectives. So we will first look into the objectives which we need to do in today's lab. So we have to create a static route on R1 that is state to get 10.61.20.0/24, go to the next hop 10.61.12.2, then place the return route on R2 stating to get into 10.61.10.0/24 to go to the next hop of 10.61.12.1. So we need to configure a forward and reverse route from R1 and R2 to reach to their loopback IP address. We will verify that routes I did operate correctly by pinging R2 loopback address interface source from R1 loopback interface. So first we will move into our objective. So before that we will do one thing. We will verify what is the current reachability and what is the current routing table. So if we do show IP route, you can able to see there are directly connected routes which is available. So these are the loopback address IP address which is directly connected, and this is the interface IP address which is directly connected. These are the directly connected routes. And if you see here, gateway of last resort is not set, means there is no static routing configuration as of now. Once it have a static routing configuration, it will show you the IP address of last resort. It means whatever the traffic will be moving out, if any of the route got failed, it will automatically forward the traffic to the last resort. We'll check the ping from router R1 to the loopback address of R2. So it will be 10.61.20.1, and we will provide the source 10.61.10.1. So if you start ping, it will show you all the packets are getting dropped. So all the 5 packets which will be transmit from the router R1, all the packet will be dropped. So now you can see success rate is 0%. All the 5 packets are got dropped. So now we will create a route from R1 to reach to the R2 loopback address. So for that we have to get into the configure terminal first. We are into the configure terminal. Then we have to type a command IP route, and we will define which network to be reached. So we have to reach 10.61.20.0, and subnet mask will be 255.255.255.0, and we have to provide the next hop. So I will show you if we do a question mark IP route. So first it will ask for the destination prefix where you want to reach. So we will type the destination prefix. This is the destination prefix. Then we will put a question mark. It will ask for the destination prefix mask 255.255.255.0, and after that it will ask you the forwarding router's address, means whatever the interface or whatever the routing part, it will ask you the next hop address from where the traffic is to be getting out. So the next hop address will be 10.61.12.2, which is the exit interface of router R1. So we have configured the static route on router R1. Okay, if we check the routing table, so we will type a command do show IP route. So now you can able to see there is a static route configured 10.61.20.0/24 via next hop address 12.0 from router R1. Similarly, we are going to configure it from the router R2. So now if you are trying to ping from R1, again it will show you the same error, because still there is no reachability from R1 to R2, because the R2 doesn't have any route. So packet is getting through to R1, but R1 is not R2. So packet is getting through from R1 to R2, but R2 is not responding to those ICMP packets. So that's why the reply packet is not coming from R2. Now we will configure the static route on router R2. So it will be IP route 10.61.10.0. Then we will provide the destination subnet mask, and now we will provide the destination next hop address. So it will be we will provide the next hop address. So it will be 10.61.12.1. and if we run the command do show IP route, so similarly you can able to see there is a static route configured for reaching 61.10.0/24 subnet, which having the AD value 1. Okay, if you see like this, show IP route 10.61.10.0/24. So now you can able to see route matrix is 0 and traffic share count is 1, and the distance for this particular static route is 1, and matrix value is always 0 for static routes. So this way you can verify the route also. You can, if you want to deep dive into the routing part, you can run this command, so it will give you the complete information of that particular route. Now we are going to ping from router R1 to check the reachability. So till now we don't have any reachability from router R1 to R2 for that loopback IP address. Now we will ping the same IP address, and now you can able to see we can able to reach all the 5 packets. So the loopback IP address which is configured on R2 is reachable from router R1. So now we have completed our first task. Moving into our next task, we have to create a static route on R2 that state to get into the subnet 10.61.30.0/24. Go to the next hop 61.23.2, then place the return route from R3 stating to get into 20.0/24 subnet. So similarly the way we have configured routes on R1 to reach R2 loopback IP address, similarly we are creating a rule for R2 to reach R3 loopback IP address. So moving into next, we will get into the router R2 first. In R2 we have to create one more static route to reach R3 router. So it will be IP route 10.61.30.0, then destination subnet mask, and then we have to provide the next hop IP address. So this way we have created the second static route, and if you run do show IP route, so you can see we have 2 static route configured on this particular router. One is this one and another one is this one. For 10.0 and for 30.0 we have created 2 static routes configured. Similarly we are going to configure on the router R3. So in R3 we will get into the configure terminal, then type IP route 10.61.20.0, then destination subnet mask, and then next hop address will be 10.61.23.1. So this is the IP routing which we have done on all the 3 routers to make the reachability from both of them. Now we will going to ping this particular loopback IP address from router R2. So we will ping 10.61.30.1 and we will give the source 10.61.20.1. So now you can able to see we can able to reach 30.1 network from router R2 using the using the source as 20.1 IP address. So this way we can achieve the end-to-end reachability from our loopback IP address which is configured on router R2 to R3 and similarly R1 to R2. Moving into our next objective, we have to configure R1 to route 10.61.30.0/24 with the next hop of 12.2. Then we have to configure R3 to reach 10.61.10.0/24 network with the next hop address 23.1. So now we have to make a reachability from R1 to R3 directly. So if we check the reachability right now from R1 to R3, it won't be reachable. So we will test it first. So we will test ping 10.61.30.1 and we will give the source 10.61.10.1. So now you can able to see currently there is no reachability from R1 to R3. So we have to provide a static route, or we can configure the static route to make the reachability from there. So we will verify where the trace is coming. So we will type a command trace route 10.61.30.1 with source address 10.61.10.1. So this will show you the path from where the packet is going on. So you can able to see the packet is not getting out from this particular router as well, because there is no route available in the routing table. So we will get into router R1 configure terminal. We will configure the static route. So it will be IP route 10.61.30.0, then destination subnet mask, then we will provide the next hop. It will be 10.61.12.2. so if you run do show IP route, so you can able to see there is a static route available in our routing table to reach the 30.0 subnet. So now you can able to see, if we do the trace route, we are able to reach till 12.2 because we have a next hop defined that we have to go via 12.2. so next hop is reachable, but still we are not able to reach 30.0 subnet because right now we don't have any reverse route configured on router R3. So now moving into router R3, we will configure a reverse route towards 10. subnet. So it will be IP route 10.61.10.0, then destination subnet mask, and then we have to provide the next hop. So next hop will be 10.61.23.1. so do show IP route. Now we can able to see we have a route to reach this particular destination from router R3 also. And if we do the trace, so now if we check the trace route, now this particular IP subnet or IP is reachable. Now if we do the trace route, it will be reachable in second hop only. And if we do the ping from this particular router R1, so we have a reachability to 10.61.30.1 network also from the router R1. So this way we can create a network, a small network which having a few routers using the static IP configuration. So this way you can configure static routing to provide the reachability from one router to another router. So I hope you find this tutorial helpful. This is a quick guide to configure the static routing on any Cisco routers. So if you have any doubts or any questions, you can comment. So stay tuned for our next video where we are exploring the dynamic routing protocols also, and also we are going to understand what are the floating routes and how we can configure the default route also on the router. Thank you so much.